Good morning to all learners in today's class. So, have you ever gone to a grocery store and asked the shopkeeper to give you 100 centimeter of sugar? No, right. The shopkeeper will probably become amazed by your question. But learners, think, if a student of class 11th makes this mistake, obviously it will give message that student does not have daily life knowledge. However, he has passed class 10th, so it is very important to have knowledge of correct units and dimensions of physical quantities. So, in today's session, we will learn the concept of units and dimensions. Assume there is 20 kg of sugar in a container and distance of school from home of a student is equal to 20 kilometer. But students say that both are equal, but it make any sense? Yes, you are correct. It does not make any sense because distance and mass are two different physical quantities. Therefore, they cannot be compared. Learners, after studying this part, we will be able to understand the concept of dimensions and principle of homogeneity. To determine dimensions of physical quantities, then to apply principle of homogeneity to solve problems related to dimensions. Learners, we have studied about different systems of units and now we will learn about dimensions of physical quantities. What are the dimensions of physical quantities? The dimensions of physical quantities are the powers or exponents to which fundamental or base quantities are raised to represent that quantity. The nature of a physical quantity is described by its dimensions. One important thing is that square brackets is used around the physical quantity to represent the dimensions of physical quantity. We know that there are mainly three base quantities: mass, length and time. So, we should know dimensions of these base quantities like length or distance can be written as m naught, L, T naught. Then dimensions of length are 0 in mass, 1 in length and 0 in time. Similarly, the mass can be represented m1, L naught, T naught. Then dimensions of mass are 1 in mass, 0 in length and 0 in time. Then we can write time m naught, L naught, T1. Similarly, the dimensions of time are 0 in mass, 0 in length and 1 in time. Dear students, earlier we have studied many derived physical quantities, out of which some are very important to learn, like area, volume, speed, acceleration, force and work, etc. Let us find the dimensions of some of them. For example, volume. Volume formula is length into breadth into height. Then the dimensions of length, breadth and height are same, that is L. Then dimensional formula of volume is written as volume equal to L into L into L, that is L cube, or we can write m naught L cube T naught in a square bracket. The dimensions of volume are 0 in mass, 3 in length and 0 in time. Dear students, in the same way we can find the dimensional formula of speed or velocity the dimensional formula of speed or velocity is written as m naught L t minus 1 within square bracket. For finding this formula, we require the formula of velocity, that is velocity equal to displacement upon time interval, that we can write v equal to dx upon dt. Now, dimensional formula for velocity, we can write L is the dimensional formula for displacement and t is the dimensional formula for time interval. Then we can write v equal to L t minus 1 or m naught L t minus 1 within square bracket. Similarly, the dimensional formula of acceleration is written as m naught L t minus 2. For finding this formula, we require the formula for acceleration, that is change in velocity upon time interval dv upon dt. As we have already calculated dimensional formula for velocity, then we can write a equal to m naught L t minus 1 upon t. So, dimensional formula for acceleration becomes m naught L t minus 2 within square bracket. Now, we can find out dimensional formula for force, that we can say that dimensional formula for force is m L t minus 2. Similarly, the force can be written as mass into acceleration, then force equal to m a, and then force equal to dimensional formula for mass is m, acceleration is L t minus 2, then it becomes m L t minus 2 within square bracket. We can also find out dimensional formula of work or energy. Basically, the energy is the ability to do work. It is written as work equal to force into displacement. As you already in the earlier slide find the dimensional formula of force, that is m L t minus 2, and dimensional formula of displacement is L. So, dimensional formula for work, that becomes m L 2 t minus 2. So, dimensional formula of speed, acceleration, force and work etc. are important to learn, because it makes the task of finding dimensional formula of other physical quantities easier. Dear students, in this way we can find dimensional formula of physical quantities, but here it is very important thing to keep in mind that all quantities do not have the same dimensions. For example, some dimensionless quantities are here like relative density, refractive index, strain etc. We should understand why these quantities do not have dimensions. For example, relative density equal to density of body divided by density of water at 4 degrees Celsius. Since in numerator and denominator physical quantities are the same, that is why it is dimensionless. In the same way, other physical quantities like refractive index and strain etc. also do not have same dimensions, because they have same physical quantities in numerator and denominator. The formula of refractive index is given by speed of light in vacuum or in air divided by speed of light in medium. Similarly, the strain can also be written as change in dimensions divided by original dimensions. So, from here we can say that in numerator as well as in denominator physical quantities are the same. That is why refractive index and strain both are dimensionless. So, now we have studied some dimensionless physical quantities. In the same way, there is a concept of dimensionless constant. Can you tell me what is dimensionless constant? Yes, you are correct. It is a constant which has no dimensions. For example, 5, 0.38, E, pi, etc. The time period of a pendulum is given by t equal to 2 pi under root L upon G. Here 2 pi is dimensionless constant. Students, there are a large number of physical quantities which we have used in earlier classes and will use in future also. If we remember the formula or we have given the formula, we can find the dimensional formula of them very easily. See the slides from 14 to 18. In these slides, we will see many physical quantities, their formulas and dimensions. Let us take slide 14. It has many physical quantities like linear density, mass density, specific gravity or relative density, time period and frequency. At slide 15, there are linear momentum, force constant, impulse, power, pressure. We can find dimensions by using their formulas. In the same way, slides 16 to 18 also have many physical quantities. Read them and learn the formula. Do practice of determining their dimensions. The dimensional formula of many physical quantities. Here, one simple question arises that what is the necessary condition to find the dimensions and dimensional formula of a physical quantity? Obviously, to find the dimensions of a physical quantity, it is necessary to know the formula of that physical quantity. If we know the formula of a physical quantity, then we can find its dimensional formula. Now, we are well trained to find dimensional formula of any physical quantity if we are provided with its formula. For practice, we will take one more example to find the dimensions of coefficient of thermal conductivity. So, for that purpose, we require the formula and the related formula is Q equal to Ka dt upon dx into T, and our aim is to find out dimensions of coefficient of thermal conductivity, that is K. Here Q is heat energy, A is cross sectional area, dt change in temperature, dx distance between two cross sections, K coefficient of thermal conductivity, T is time. Now, we have to find dimensional formula of coefficient of thermal conductivity. So, the above expression can be written as K equal to Q into dx divided by A into dt into T. Now, we have to write dimensional formula of right hand side. By substituting all these dimensional formula in that right hand side of this formula, then we can find out coefficient of thermal conductivity. Here Q is the heat energy which has dimensional formula same as work, that is mL2 T minus 2. Now, substituting the value of all physical quantities dimensional formula in formula of K, then it becomes mL2 T minus 2 L upon L2 theta T. After solving it, it becomes K equal to mL T minus 3 theta minus 1 within square bracket. Thus, the dimensional formula of coefficient of thermal conductivity becomes mL T minus 3 theta minus 1 within square bracket. Learners, we will find that there are so many physical quantities having same dimensional formulas. For example, impulse and momentum, work, energy, torque, moment of force, angular momentum, Planck's constant, rotational impulse, stress, pressure, modulus of elasticity, energy, density, force, thrust and many more. We can prove that in above examples, the mentioned physical quantities have the same dimensional formulas. The formula of linear momentum equal to mass into velocity. Now, we have to substitute dimensional formulas of mass and velocity, then it becomes P equal to m into L t minus 1. Finally, the formula for linear momentum in terms of the dimensional formula becomes m L t minus 1 within square bracket. Similarly, we can find out dimensional formula for impulse, that is force into time, and dimensional formula of the force that we have already find in earlier slides, that is m L t minus 2 and time is t, then it becomes m L t minus 1. Then you can see that dimensional formula of linear momentum and dimensional formula of impulse both are same. So, that is why we say that both have the same dimensional formula. Now, let us assume a case. A lady went to market, she purchased 10 meter cloth and 20 kg flour. Her husband asked her, how much total you purchased? In your view, what should be the answer? Actually, there is no answer of this question, because meter and kilogram are the units of two different physical quantities, that is length and mass. So, they cannot be compared, but there is a law related to it which is known as principle of homogeneity. The principle of homogeneity of dimensions is the similar quantities can be added, subtracted or equated. We can understand the use of this principle of homogeneity with the help of following examples. Example 1, initial velocity can be added to or subtracted from final velocity, because they have same dimensions, that is m naught L t minus 1. Similarly, we can take example 2, but force cannot be added to acceleration because their dimensional formulas are different, that is for force dimensional formula is m L t minus 2 and for acceleration L t minus 2. Dear students, the principle of homogeneity is very important. It can be used to determine dimensional formula of unknown physical quantities in any equation. For understanding this, we take one example in which you have to find out dimensional formula of unknown physical quantity A and B in following equation, like x equal to a plus b t, where x is distance and t is time. Now, by using the principle of homogeneity, we can say that a equal to x, because according to the principle of homogeneity, same physical quantities can be added. So, that is why a equal to x, then dimensional formula of a becomes m naught L t naught within square bracket. Similarly, b t is also equal to distance, then b t equal to x or a. Then on simplifying it, we can say that b equal to x upon t. Now, we have to substitute dimensional formula of x and t, then it becomes m naught L t naught divided by t. Now, the dimensional formula of b becomes m naught L t minus 1. We will take one more example to find dimensional formula of unknown physical quantities. Now, we take example 2. Find the dimensional formula of a and b in the following equation. Here a and b are the unknown physical quantities. P plus a upon v square, v minus b equal to R t, where P is pressure, V is volume, T is temperature, R is universal gas constant. Now, in the given equation, P plus A upon V square, V minus B equal to R T, we have to apply principle of homogeneity. So, here you see that in this bracket, first bracket, the pressure can be added with pressure. So, that is why A upon V square, that must be equal to pressure. In the second bracket you see that V minus B. So, same physical quantity can be subtracted. So, volume can be subtracted from volume. So, that is why B is volume. So, we can write A upon V square equal to P, then A equal to force upon area, then P upon A into V square. Now, we have to substitute dimensional formulas of force, area and volume. Then you will get A equal to ml T minus 2 and volume is L cube and it is square, that becomes L raised to the power 6 divided by area L square. Simplify it, then we will get A equal to ml raised to the power 5 T minus 2 within square bracket. Similarly, we can find out dimensional formula for B. So, B equal to volume, then B equal to L cube. Therefore, dimensional formula of unknown physical quantities A and B can be written as A equal to ml 5 T raised to power minus 2. Similarly, B equal to m naught L cube T naught, both are in square bracket. Learners, there is an assignment for all of you. Its practice will make more clarity in the concept of dimensions and its uses. Now, the first assignment is gas equation given by the formula P V equal to N, where P is pressure, V is volume and number of moles, K Boltzmann constant, T absolute temperature. So, in this equation you have to find out dimensional formula of Boltzmann constant K. Another assignment for you, the velocity of a body is given by V equal to AT square plus BT, where T is time, then you find the dimensional formula of A and B. So, students, we have discussed a lot of concepts today. What did we discuss? We discussed about concept of dimensions, dimensional formulas of various physical quantities, principle of homogeneity. Now, I will conclude my session with a very famous quotation which is written in Bhagavad Gita, that is, right knowledge is the ultimate solution to all our problems. Thank you.